Hello everyone. Here I am going to do two examples using the double and half angle formulas. So in my first example, it's asking to find the cosine of 105 degrees using a half angle formula. So I'm going to copy down the half angle formula for cosine, which is cosine of theta over 2 equals plus or minus 1 plus cosine of theta all over 2. All right, so that is the half angle formula for cosine. So now, to figure out what the cosine of 105 is equal to, I need to make this part right here and that part right there look the same. So I have to have something over 2 to be able to use that formula. Well, the only way to get 105 is if I would double that and say, okay, 210 over 2. Because now that's the step that really confuses most students. So 105 is the same as 210 divided by 2, which that makes sense. And the only reason that we do that is so that it looks the same as the formula. So we have 210 over 2, which is the same as 105, which is better for us because now it looks like theta over 2. And so then the nice part about this is that the 210 is the theta. And 210 is an angle that we know lots of things about because it's in one of the special triangles. So let's keep writing plus or minus. We'll deal with that at the end. And then following the formula, it's 1 plus the cosine of theta, but now we know that theta is 210. So we have that all over 2. All right, so plus or minus 1 plus. Now I know the cosine of 210. I can show the work for this. 210 is here. It's 30 degrees away from 180. So the special triangle would be -1, 2, negative rad 3. And since cosine is adjacent over hypotenuse, it would be negative rad 3 over 2. So that's what I'm going to put right here. Some of you might just have that memorized and not even have to draw the angle, but whichever way you do it is fine. Now this square root is over the whole entire thing. All right, now comes the simplifying. This is also usually a tricky part for students. So I am going to make a common denominator. So we have 1 minus rad 3 over 2 right now, like this. So I'm going to change this 1 into 2 over 2. So then I can do plus or minus 2 minus rad 3 over the common denominator of 2, and still divided by this other 2 in the bottom. Maybe think of that as divided by 2 over 1, because then we could just multiply by the reciprocal. So that's gone. And then that gives us 2 minus rad 3 over 4. And the last thing that your teacher, I'm sure, would like you to do is 4. This 4 on the bottom has a perfect square root. So how about if we go like this? Put the square root only on the top around the 2 minus rad 3. And then put that all over the square root of 4, which is 2. And then we have to pick the plus or minus. Now the plus or minus is based off of the original angle. So the original angle was 105. And the cosine of 105, which is in the second quadrant, if we think about the unit circle, cosine in the second quadrant is negative. Now some of you might do it by the little saying, all students take classes or calculus. So the second quadrant has an S in it, which means cosine is negative there. So we would pick the negative. So you highlight that. So our final answer is going to be just the negative only, square root around the top, all over 2. And that would be our final solution. Now the second problem I've picked is one of those where you have to prove that the given equation is an identity. And this one involves the double angles. So I have listed the double angle formulas at the top up here. The tricky one is cosine of 2a because it has 3 different versions. You can use any of the 3, but there usually is one that would work the best in the problem that you're in. So this is an example that has that, and I'll show you how I usually pick. So the first thing is to work on the messiest side, which is definitely the left-hand side of this problem. So we're going to try to change this side so that it becomes cotangent of A. So the first step would be the numerator. That's the sine of 2a. If we look up at our formulas, we know that that is equal to 2 sine of a cosine of a. So I'm going to change that. 2 sine of a cosine of a. All right, now the denominator, there's a cosine of 2a down there, which is right there. And I am going to pick this middle version to use. The reason is because, if you notice, there is, let's see if I can highlight this, make it blue. There's a 1 minus in front of the cosine 2a. So if I put a 1 minus in front of this version of the formula, it would cancel out the 1 that's in that version. And that's the only one where it would cancel, because if we picked this third option, it would be 1 minus a negative 1, which would add up to 2, and that's not really going to help us out. So that is the reason why I'm picking the middle formula. So when I do that, I'm going to rewrite 1 minus, and then in parentheses, that middle version, 1 minus 2 sine squared of a, and then the other side, cotangent a or not touching. Let me just change the highlighting here so that you can see exactly what got replaced. Okay, so that became that. All right, so the yellow became the new yellow, and the green highlighted part became the new green that I picked. So now we're going to simplify the denominator. 2 sine of a cosine of a is still the top. And in the denominator, I can distribute the negative through the parentheses, so it'll be 1 minus 1 plus 2 sine squared of a equals cotangent. Now this is exactly what I wanted to happen. 1 minus 1 subtracts out. So that leaves us 2 sine of a cosine of a over 2 sine squared of a. And we still want that to equal cotangent. All right, now the 2's will divide out. The sign on top will divide out one of the signs on the bottom, so we can just slash off that squared power. So let's bring this to the top of the next column here. Now we have the cosine of a on the top over the sine of a on the bottom, and we're trying to get it to be cotangent. And well, cotangent is cosine over sine. So we could just say cotangent of A is what we have, and that is equal to the cotangent of A that we wanted it to be equal to. Check. and you're done. And so the teacher would be checking through all the steps of your work just to make sure that you arrived at your answer the right way, instead of just writing cotangent equals cotangent, which you could do, but you wouldn't get any credit for it. And so that is a good example of how you can use the double angle formulas to prove an identity, especially showing you how to pick strategically which cosine of 2a formula to use.